Okay, everyone, we're going to get started a little early because this is a great topic for discussion, and I want to make sure that there's time to bring in a lot of voices. My name is Dan Schrag. I teach here in Earth and Planetary Sciences, in the School of Engineering and Applied Sciences, and also at the Harvard Kennedy School. What we're going to be talking about today is the idea of solar geoengineering. Solar geoengineering, for those of you who don't know, well, probably all of you do know, but essentially it's the idea that we can counter the effects of adding greenhouse gases to the atmosphere, counter some of the climate impacts by reflecting sunlight out of space. Now, there are a number of different strategies that have been proposed for how to do it, but the dominant idea is the idea of putting aerosols up in the stratosphere, and they last anywhere from 6 months to maybe 2 years, and reflect sunlight to balance out. Now, scientifically, as we'll hear in a minute, the idea that this should work is actually physically, when I first heard about it, I thought there's no way this could actually work, but it turns out our best evidence says that it actually does a remarkably good job at not eliminating the impacts of higher greenhouse gases, but certainly reducing some of the most extreme impacts. That being said, this has always been almost a taboo subject. This has been a subject that we've been talking about in the scientific community quietly for decades. It was actually mentioned in reports in the Lyndon B. Johnson administration. So this is an old idea. But almost 20 years ago, 2007, my friend David Keith and I hosted a workshop here at Harvard. And it was really one of the first big workshops on this subject. It was considered radical, and many prominent climate scientists said that they didn't want to come to the workshop because the topic they didn't believe should even be discussed. That's interesting. That was 17 years ago. Now there's actually a big scientific community that's working on this, and also outside of the sciences, social scientists, people in law and business and political science, thinking hard about how to manage these systems. What are the governance issues of the system? And so today we have an extraordinary group of people. I'll just introduce them very briefly because you have their bios from the program. My colleague Frank Koich, an atmospheric chemist who's been thinking about solar geoengineering intensely for the last decade or so. Britta Clark, who's just finishing her PhD in philosophy here at Harvard. Britta is writing about solar geoengineering and the ethics of it, and is also going to be an environmental fellow at the Salata Institute in the fall, starting a postdoc fellowship. Billy Pizer is here. Billy is the new president of Resources for the Future. Just started his position in May, and we're very delighted to have him. And then my colleague Robin Wordsworth, who's also in Earth and Planetary Sciences and in the School of Engineering and Applied Sciences. And I want to start with Robin because Robin is somebody who thinks about radiation. In all of the different types of climate scientists, this particular problem of reflecting sunlight as opposed to greenhouse gases that absorb infrared radiation, the details of that physics depend on essentially the details of radiation. And that's really where Robin makes his specialty. So Robin, in this discussion, and we're going to try to keep this pretty informal today, but Robin, I want to ask you to start off. When you first started hearing more and more about solar geoengineering and the discussion of anthropogenic climate change, as a scientist who mostly studies extrasolar planets very far from the Earth, are you surprised that it works as well as it does? Reflecting short-wave sunlight is very different than reducing greenhouse gases. So why does it work so well?
Yeah, thanks, Dan. It's an honor and perhaps a challenge to start off this discussion, so I'll do my best. As Dan mentioned, I'm a planetary scientist, so I do think about Earth climate change, but I spend most of my time thinking about the climates of other worlds, so long-term evolution of Mars, Venus, planets around other stars. And one thing that gives you is a perspective on how stable planetary climates are generally. I mean, we tend to think of the climate of a planet as something which is typically quite difficult to shift, but under certain circumstances you can get pretty rapid changes. And so Venus is a permanent example. It's a very, very extreme case of a planet where you have a haze layer, which it turns out completely determines its climate. So I teach a grad class in radiation, and one of the calculations that we ask the students to do is exactly this solar geoengineering problem, where you say, I'm going to take a certain amount of SO2 and I'm going to put it in the stratosphere, and I'm going to calculate for the given amount of planes going up there and depositing that material, what kind of reinforcing am I going to get? I use it as a vehicle to teach the students about radial transfer, but the answer they get, if they do the question correctly, is really surprisingly small. It's something of the order of, I don't want to quote exact numbers, but a dozen to 100 jets or something like that would require of the orders of possibly tens of billions of dollars per year, which is kind of a shocking answer. And it comes down to the fact that aerosols can have a really outsized impact on radial transfer. Size of the aerosol is extremely important. So this is the question of the surface area to the volume of the particle that determines the impact. I think Frank will have something to say in just a minute about how this ties into chemistry, because it turns out chemistry and microphysics are important for all of this. Many of these things we don't fully understand very well. But we do know something historically from Earth's own record of the kind of effects we should expect, because large volcanic eruptions tell us order of magnitude what kind of forces we should get. So Pinatubo in the early 1990s, for example, was a sort of textbook case of, in the satellite era, an eruption that caused a measurable cooling of the climate, and so that's used as an example of what we expect should occur. So it looks like it's something that should indeed have a large radial impact, but when you're talking about climate, Earth is a very complex system, and there's many other effects to consider. Precipitation is one of them. Effects on the carbon cycle and other things, but
so Robin, that's what I was going to push you on a little bit. So greenhouse gases are there all the time in the atmosphere. Carbon dioxide lasts for a very long time in the Earth's atmosphere, and the Earth's constantly emitting heat out into space. It's engaging with those greenhouse gases in the atmosphere, whereas putting reflective particles in the stratosphere only matters during the daytime. There are all sorts of ways that they don't cancel out necessarily. And we usually talk about, well, how does it affect the global average temperature? But there's a lot of climate experience that doesn't, in fact, most of our climate experience doesn't really scale with global average temperature necessarily. Right,
and so for example, once you go beyond the kind of zero-dimensional model experiment or the back-of-the-envelope calculation, you have to think about, as Dan just said, daytime versus nighttime effects. Latitude also matters, so the aerosols are going to have different radial effects at poles from the equator. And also, we always talk about reflection, and that is the most important thing, but most of the aerosols that are generally considered in geoengineering also have infrared effects, and so you have to think about the effects on upwelling radiation that can shift both what temperature does on the surface and also temperature of the upper atmosphere, and so there's potential knock-on effects for circulation and even chemistry in the stratosphere.
So do you trust most of the papers that talk about the effectiveness of this approach? Do you think there's a potential for some big surprises?
I've done a lot of work building complex models, and that makes me inherently distrustful of models that are large. I think it's super important to do back-of-the-envelope calculations and gut checks as you go along, and also laboratory experiments, because our best models are only ever as good as the laboratory experiments that constrain them. So my take on this, as someone who knows this field but doesn't work tons in it, is that we're still in the early stages of understanding what the manifold effects are likely to be from this kind of climate experiment.
Yeah. So Frank, that leads us to you. As an atmospheric chemist, you've started to go beyond laboratory experiments, even proposing a field experiment. What do you think about this sort of readiness of this kind of approach?
Right, I think that the reason to sort of think more about field experiments or use observationalists, and I will say that I'm not objective on this because I'm an experimentalist, not a modeler, although we're now using global models as well. is to really sort of try and test certain aspects of the model. What I would say is that the models in broad strokes and first order, what they say I probably trust. But the issue is, in the end, nobody lives in this average world. People live in specific regions at specific locations at a specific time of year. And so it's not good enough to sort of think, oh, roughly you get the temperature of the globe, back to where it was or something like that. You really need to understand better what is driving local and regional processes. And for that, you really have to understand the details both of the chemistry that's occurring, but also sort of the coupled dynamics that in the end give you these regional aspects. And I think that is where just using models is too limited, because a lot of them are really highly parameterized. And for example, if you consider Mount Pinatubo is the volcanic eruption everybody always references. And so that models by now can do a pretty good job of reproducing certain aspects of Mount Pinatubo. It's actually not that surprising. You'd hope that by now they could do this. This was in 1990. How does it look for other perturbations? It looks quite different. And this idea, also Mount Pinatubo is one pulse. The volcanic eruption puts particles in the stratosphere, and they stay there for, say, roughly 1 year, and then they're gone again. Does that have the same impact on the climate system longer term than if you do a continuous injection for, say, decades? There are different time responses in the system, both chemically and dynamically. And so it is not clear that one has to be aware that the comparisons have been done, like with Mount Pinatubo, are quite limited because they are not the same thing. And what I think we need to do is, I'll give one more example, and then I hope that I can show that. In the climate model, the particles that are put into the stratosphere appear magically in the grid box of the climate model, which is on the scale of hundreds of kilometers typically in the stratosphere. And they appear in the way that the scientists think they should be, the size, whatever they are. Now, if you actually you took a plane to say 20 kilometers and you inject from a point source and make a plume that slowly spreads, whether that in the end, it can be the same amount of material. I'm putting in the same 1 million tons per year just to give you an idea of the scale. Does that really end up, at what point, if ever, does that end up the way the model actually starts out with? Isn't really open question. And there are things we can use. So what for example, my group is looking at is, can we use things like wildfires, these big, actually I shouldn't call them wildfires because that makes them sound too natural. The big fires that have so much energy they inject into the stratosphere. Big convective events that inject ice to like 19 kilometers. There's a lot of events, rocket plumes, that we can use, for example, to also learn about how material spreads in the stratosphere. So there just hasn't been enough work really verified. And what people have done, I'll swear this is the last thing I'll say. What people have done in models, they look at the impacts. They want to know what's going on to hydrological cycle, what's going to happen to these different things. They haven't done enough of saying, given our physical and chemical understanding, does it actually make sense that this happens? People haven't looked under the hood.
So before we even get to the impacts, just putting the stuff in an airplane and sending it out into the real stratosphere is a chemically dynamic system. Lots of radiation. Even the size of the particles is not simple, because when you put real things in the stratosphere, they clump, they separate. Trying to predict exactly how real material will behave when it's up there, it's not so easy, right?
That's absolutely correct. In fact, we just did a comparison of one of the state-of-the-art, my students, I should say I don't really do it, I think it's all my students. So my students compared, we were on a stratospheric aircraft with NASA, nothing to do with geoengineering. There happened to be a volcanic eruption that year, a small one. And we tried to compare what the model said compared to the observations. And there's quite a bit of uncertainty, and the model gets a perturbation right, but it doesn't get the total amount, the size of the aerosol. So and then you take different models and compare for the same amount of sulfur I inject in the stratosphere. You can get very different amounts of radiative force. And so these are all things that show you that we don't really understand the processes well, I would say well enough at the moment to really have faith in what these predictions exactly say.
So I want to ask you one more question before we move to Billy, which is, so you mentioned sulfur, which has always been assumed to be what we will do because it's what volcanoes do. But based on our understanding of stratospheric ozone, is sulfur a good idea? There's been a lot of discussion about whether actually we need to find something else completely.
That's right. So there's now a movement to study alternative materials that may have less side effects. So I always like to say that sulfur is the devil we know. And there are other materials, and there's two things. Most people focus on the ozone. What's actually, in my opinion, a more dispensive effect is what Robin referred to, the fact that these sulfuric acid particles absorb this terrestrial infrared outgoing radiation, and they heat up the stratosphere. And the same way you have a pot of water in the stove, if you turn up the heat, you can see how the circulation in that pot is changing. If you heat up the stratosphere, you're going to change stratospheric circulation. And the circulation is in a highly complex coupled system. You couple to the troposphere, you're going to couple to ocean circulation. You're starting to dial a knob that we don't understand so well. So there are other materials that can be investigated that should have much lower chemical and much lower stratospheric heating effects, but as they don't exist naturally in the stratosphere, we actually don't really know that very well.
Yeah. And for people who don't know the details of the climate models we use to predict impacts of climate change, you should understand most climate models that we use don't even have, they barely have a stratosphere at all. We don't consider that relevant to predict, but clearly it will be. So there are big science questions, there's big technology questions about how to do it, but Billy, you're an economist. You're first of all, just the fact that the president of Resources for the Future is here talking about solar geoengineering, I can tell you as somebody who's worked on this for a long time, 10 years ago that would have been radical. It's not radical today. What does that tell us? I mean, there's big issues that are not science and technology issues, right?
Yeah, totally. And maybe I should just start by saying, for those of you who are not familiar with Resources for the Future, we are an independent, nonprofit, nonpartisan research institution in Washington that uses economics and policy engagement to improve environment, energy, and natural resource decision making. So I had to get that out. Yeah, I mean, if you think about everything that was just talked about so far, there's a big technology question, but you can kind of quickly imagine how this is not just a technology question. This is something that affects humans, it affects society. And we have to figure out, as humans and as a society, how we're going to manage that. And I personally I was telling Dan beforehand, this was something I always imagined we'd be talking about like in 50 years. And then I heard, I don't know, Joe Alty and I were kind of doing a listening tour maybe 5 or 6 years ago. I realized that all these environmental organizations actually had people dedicated to studying solar geoengineering. And that was when I realized we weren't talking about 2090, we were talking about 2030 or 2040, and I realized we needed to start thinking about the social science aspects of this and how we would govern it, how we would deal with the risks that doing something like this might affect or change our impetus to do mitigation. How do we create a portfolio of an intervention in the stratosphere with mitigation, with adaptation, with carbon dioxide removal? Like, there are all these questions about how we would both make decisions and also how it would fit in or might not fit in with other activities that no one was thinking about. And that was why we realized this was a really important topic for economists and other social scientists to begin thinking about, because it's not just a technology problem. The technology may be the easiest piece, to be totally honest. Yeah. It's all the other pieces that are really hard.
So let's dig in. What do you think are the biggest issues? Where do you think there's some hope of figuring this out? I mean, part of the reason that I've always advocated working on this over the last 20 years is that I feel like we have limited time before, because we don't get to decide who gets to use it or whether somebody uses it. They're unlikely to ask some pinhead academics, right? So the real question is, how can we understand it in a way that will actually maybe influence the thinking of people who might have the power to make this decision in the future? So what are the big levers we need to be thinking about?
Well, certainly there's been a lot of discussion about governance and what sort of global system or subnational system should be used to make decisions about research and maybe at some point in the future implementations. I think mainly the questions right now are all about research and how you would govern the research and how do you make it equitable and fair to poorer countries in the South who may be affected. How do you make it transparent? How do you avoid the private sector having an undue role? All these questions. But honestly, I think the bigger question to me is, if we look at how successful global governance has been at solving climate change on the mitigation side and dealing with the inequities, it does give you pause to think that it would actually be particularly effective in dealing with the governance of something like solar geoengineering. So the other big topic that I've been particularly interested in has been thinking about what realistic scenarios might look like when you don't have global governance and you have a country that's desperate, taking action on its own because it feels like it has to do something. Those sorts of scenarios, I think, could actually inform more research on the physical side about the kinds of physical scenarios that may be relevant for actual deployment or experimentation.
Yeah, I share your opinion that a lot of the previous work on governance is a little bit utopian and idealistic and unrealistic in the context of imagine sometime in the future when climate change is not just something that, well, there's a COP meeting and there's some commitments or whatever, but actually leaders of government are actually, and people are actually afraid. And they actually have real political pressure to solve it. That's the environment where you would say, okay, how do world leaders and powerful world leaders like heads of state of the US, of China, et cetera, how do they manage this problem in that context? Not today, but sometime when people really are afraid.
That's right. And what's the research we can do now to make that less chaotic?
Right. So one of the perspectives on that comes from ethics and philosophy. And Britta, this is what you've been thinking about for the last several years. Now, it's not very usual for philosophers to have profound effects on the way that world affairs are run. I mean, we can look at all sorts of things going wrong in the world today and imagine that a panel of philosopher kings would, or kings and queens would be in charge. But at the same time, there's some really important dialogue here. So you just heard Billy. What is your insights think about how to reframe this problem?
Yeah, thanks, Dan. I think, first of all, philosopher kings and queens shouldn't be making the decisions about this sort of thing. I think one of the reasons this panel is so great is because we really need all the voices across the physical sciences and economists and so on. And oftentimes people think, oh, the philosopher is going to come into the room and say, like, here's what you should do, here's what's right and what's wrong. And philosophers do that, but a lot of my work, at least I'm in like the early stage of my career, and a lot of my work has just been taking a step back and trying to clarify the terms of the debate. So I think, Billy, I really appreciated your point about realistic modeling efforts, because oftentimes people sort of cherry pick assumptions that fulfill the sort of technology or lack of technology that they're interested in. So sometimes people will say, look, as you brought up, I'm really optimistic about solar geoengineering and the prospects of a just and equitable governance scheme. But I'm really pessimistic about the chances of a rapid and just global energy transition. And one thing I've tried to do is say, look, those are inconsistent assumptions. Like, if you're going to make those assumptions, at least you need to justify it. And on the opposite side, critics of solar geoengineering will often say, look, I think we can do it. Like, we can reach the 1.5. We have the global capacity. But then they're really pessimistic about the prospects of a just governance scheme for solar geoengineering. So I think taking that step back before you even get to the questions of, like, should we research, should we deploy, is a really important first step, at least. And we can't stop there, but first place to go.
So I have a question for you, but it's really for everybody. And I hope this will now devolve into really a conversation. It's about control. You know, we especially with this issue of solar geoengineering, there's the concern, we tend to be more sensitive to errors of commission versus errors of omission, right? So we hold solar geoengineering because we would be doing it to a much higher standard than errors of omission, like not reducing greenhouse gases, greenhouse gas emissions. We don't necessarily treat them equally when we think about them, because there's something, we have a particular problem and we're maybe more responsibility. And this gets to this question of control, and it gets back to technology, it gets back to the physics of it, which is do you think it's a good thing that we actually, the veil of uncertainty around exactly what's going to happen and exactly how the particles are going to, in some ways that means that it's very hard to predict exactly what's going to happen. That sounds in some ways bad to a scientist, but in some ways that could actually be a good thing, right? Because we're trying to intervene to help things, and if you don't know exactly what's going to happen, it limits your responsibility. Is that fair?
Yeah, I mean, I think this question of intention is a really interesting one, and one thing philosophers love to argue about in other contexts. And it's interesting that the discussion of solar geoengineering has relied on this definition that's like large-scale intentional manipulation of the climate, when really, we're doing a lot of this already, both from just releasing greenhouse gas emissions and things like we saw with the shipping regulations on shipping emissions raise global temperatures by a small amount. So I think there's deep and interesting questions about whether our intention to do good or to have some effect bears on our responsibility for the outcome, and how those things are related. And like the physical sciences and the chemistry, those are, in my mind, deep and unanswered questions at this point.
Yeah. I mean, I'll tell you, there was years ago at this conference, there was a protege of Edward Teller. I won't say his name, but I found him terrifying. He got up and said, we now have the technology to provide everyone on the planet a Mediterranean climate. Now, the fact that he had no context for how totally ecologically inappropriate that was for this planet, but think about it for a second. If you actually had that level of control, if you could actually figure out how to engineer the specific climate for every place, wow, now that makes governance really complicated. Whereas if you're basically dialing one big dial and saying, I'm putting more or less sulfur in the stratosphere, or maybe I'm putting it in a few different places, so I have a couple of dials. That sort of limits the governance range of discussion, doesn't it? Does that matter, Billy?
I guess I was trying to get at whether or not the goal by living in the veil of uncertainty was to limit the intervention. It sounds like the goal is to limit the intervention and not get to these situations where people may be fighting over the thermostat or something. But I think, if I understand it right, I mean, the intrinsic assumption is that you can actually keep people from going to this technology. Or
I wasn't thinking about it that way, but maybe.
Well, then if they are going to the technology, I guess my feeling is we're not yet at the point where we even know what those 3 dials that you had work. I mean, I think we're a long way from being able to give everybody a Mediterranean climate. It seems like we don't even know which particles to inject or what latitudes to inject them at, or to understand what a country in a dire situation, and they didn't have the technology to get it into the stratosphere, what their intervention might look like and what that might do, and being able to plan for that. I think it's really trying to be ready for some of those eventualities that are likely likely in the next decade or two. That's what worries me the most.
Right. Was your thinking at all affected by Kim Stanley Robinson's book, Ministry for the Future?
It came out after we started doing our little conversation, and I think I read it about the same time that I found out about the war game exercise that the National Intelligence Council did. So it all fit into the same narrative, though, that you would have some countries that were facing, an inordinate climate impact and felt desperate and had to take action. Mm-hmm. And that sort of scenario is certainly the one that's been motivating me. So it fit into the narrative in some sense that I had.
Yeah. So do you see work on this and the kind of research you're thinking about doing and the kind of research Frank has been doing? Do you think it's becoming more normalized? I gotta say, it's still pretty difficult. Feels difficult.
It's certainly now, I guess, people are talking about it. You're having this event here. We're doing a workshop with Harvard in September again. So it's definitely more prominent than it was 5 or 10 years ago. But it's certainly still too controversial to do a lot of the experimental research, that Frank's group was trying to do, and other folks were interested in moving forward with.
Yeah, why don't you tell us about that experience, Frank? As a scientist, how do you think about the public resistance, the public fear of this?
Well, as a background for people here, perhaps, we were planning to do, what we wanted to learn scientifically is how if you inject something in the stratosphere, how does that evolve over the first few kilometers, say 4 or 5 kilometers, to then learn how this goes on. As I said, this is one of the big uncertainties. And we wanted to do a test of a new stratospheric platform. Doesn't really matter exactly what it was, balloon driven. And we weren't going to inject any particles at all. However, I'm a physical scientist and I don't know anything about governance. And we talked to lots of people and they gave us advice to have an external advisory committee and have a certain process this would undergo. And it was, I would say that in a way this experiment was actually as much an experiment in governance as it was of science.
Not governance of solar geoengineering, but governance of the project.
Of a single experiment, right? Not governance of solar geoengineering, governance of a single proposed experiment. And fundamentally what it showed is that the governance process in retrospect was set up in a flawed way, in quite obvious ways. This was not clear at the beginning. The people who were giving us recommendations, the people who were part of this were really high level people with a lot of experience in this field. And in retrospect, it was the process was set up in such a way that it couldn't respond in a nimble way to sort of evolving situations that had to do with engagement of the public. And so that was actually for me quite an important lesson. I actually still don't quite know what the right way of engagement is. You know, if you do a local experiment, I do a local experiment here where I spray something and then you guys are going to say, well, wait a minute, I want to know whether that does something to me. There's like a local group that's directly affected. Then you can beforehand go to that group and talk to them and either work together and they'll say, yes, this sounds fine, or you say, no, hell not here, and then you don't do it there, that's fine. If you do something in the stratosphere, not even injecting particles, who on earth are the people you engage with this? There's actually nobody affected. So that's still a really challenging question. It is not straightforward how that actually should work. And I haven't heard anybody come up with a clear answer for that. So it's quite a fascinating, just a single experiment in the stratosphere is a fascinating governance problem.
I mean, I do think it depends what you mean by effect and what sort of time scale you're looking at. So sure, if you're testing a weather balloon site, there's no one who's, seeing increased pollution and no one who's experiencing any physical or environmental impacts. Mm-hmm. But it might be that people are looking ahead to the long term, and obviously there's the big sort of mitigation, inhibition, moral hazard concern, or just the concern about not being consulted in the future and so on. So I do think if you take a wider view of effect or impact, it may be that just doing this thing in the stratosphere does have an effect or an impact under that wider definition.
But under that wider definition, couldn't anybody on the planet claim that wider impact?
Yeah, I mean, you might go that direction and say, and some people do, I wouldn't go that way. We'd say, like, look, this is sort of a global issue and we need some sort of global consensus. That seems too strong. But I think there's probably some middle ground in between the no one's affected and all affected principles.
Sure, but where is that? Who should you engage with this? I agree with you that this was clearly the resistance in part came from mistakes that were made on our part, but part of it is not about that actual thing, it is about what it stands for. But then that still doesn't help me say, well, who do you engage with? In a sense, you're opening it up to the entire world. You can't ever ask the entire world for global consensus. That doesn't happen for anything. And as soon as you try doing that for a single experiment, fundamentally you're saying such experiments can never happen.
So I guess I have a question for both Robin and Billy, which is, do you think the fact that there are more and more conversations about this, do you think that the discussion of this is more familiar? Well, it's still new to a lot of people, but it will become more and more familiar, presumably in the years ahead. Do you think that helps with this problem? Do you think part of this is the newness?
I mean, sure, I could start. I mean, when I first heard of solar geoengineering, I worked with climate scientists whose stance was, this is a terrible idea. It's such a terrible idea that we shouldn't even research it, and even talking about it is not an effective
He was
approach.
one of the ones who refused to come to our workshop.
And you know that was kind of where I started thinking about this problem, and it's interesting. There's certainly big sectors. I think it's a fair statement. There's big sectors of the climate community who still hold that view, and some of the resistance, or a lot of the resistance to experiments, comes from that. I don't know. This back and forth was just reminding me. I mean, I think physics is challenging, but global governance is like a whole different issue altogether. But I mean, where I've got to on this question is we are in the Anthropocene now. We're stewards of this planet, whether we like it or not, and we've kind of reached a point where if this was something that was being considered in a vacuum, then obviously it's a bad idea. But that's not. It's not really that we can think about this versus the alternatives in a kind of neutral way. You have to consider the solar geoengineering versus different scenarios where there's different amounts of drawdown of CO2. And so my stance has evolved to the point where I think that research on this topic, scientific research, is worthwhile. I don't think we know enough yet to go much further than that. But yeah, I think clearly when you have something so controversial, there's always going to be sectors of the climate community and the wider community that are very against it. I think it's challenging to make progress under those circumstances, and I'm interested in how it's going to evolve.
I would just make two observations. One is, if you look at the discussions of adaptation to climate change, 25 years ago there was a lot of resistance to even talking about that.
Not even 25, even 10 years ago.
Yeah, 10 years ago. Time is hard to parse for me.
Yeah.
But the dam broke on that, and the impacts of climate change were significant enough that people could not ignore having conversations about adaptation. So, I think that is, that's an important lesson for us here, that it takes a certain amount of socialization, it takes a certain amount of recognition of how serious the problem is, and that this is something that, we can't just go forward without, having a more serious conversation about it. And, I think the second thing is just, I think people have to grapple with, this is something that may happen whether you want to talk about it or not. And if you don't want to be surprised by it, you need to get ahead of it. And I think national security people and other people are going to begin to think about this as something they can't just say, we're not going to do anything. I mean, I think the governance question, you had the Climate Overshoot Commission come out with a set of recommendations last year that we could talk about. You had the different governments, the U.S. government, European government, kind of beginning to tiptoe into this topic. So I think you're seeing changes.
Yeah. So I want to bring the audience in a sec, because I'm sure they have a lot of questions and discussion. But before I do, I just am curious with this conversation. Do you see this as a really exciting, growing topic? I mean, all of you are working in it to some extent. Maybe it's not your only thing you're doing. There are other things that each of you are working on. But I'm curious, the resistance, the almost taboo nature that this subject had for so many years. And by the way, we've been trying to resist that at Harvard and fund research in this topic because no funding was available pretty much from federal agencies or anywhere else. But do you think is this going to change? Is this going to be part of the mainstream? What do you think?
I think it's definitely. The first thing I would say is I wouldn't call it an exciting. I would say it's sort of perhaps exciting in an awkward way topic. I do think it's growing. The research field is growing. Just as one example that's interesting is that the UK, there's a new agency that came out. It's called AREA, which is a version of ARPA in the US, and they actually now have an explicit call where they want to fund solar geoengineering research, including experiments, not necessarily field experiments. So it is definitely a growing field. One of the things I'm doing, which I think has worked quite well for me, is that as part of lessons, I'm explicitly in the research I'm doing, making it international from the get-go. Every research project has international components, it has international researchers, and I can say that, for example, in the sort of global south, although that is perhaps not the best term to use, but people know what I mean. There's very large interest in this, and it's not that research that people there are more in favor or not, but I think they're more scared, and so they just want to know could this be an option or not, more than in the Western countries. And so I've been and worked to have a project with researchers in Brazil and sort of all over the world. That's sort of my approach. And in that sense, I see it growing because people in other places in the world are quite interested in being part of this research. So that's a very research community focused aspect, but I do think in that aspect it is clearly a growing field. It's still very small, but it is growing.
Anyone else?
I'll just say, I don't use the word excited. I think that was the word you used. I see a number of people in our circle that have a range of views. I probably land more on the frightened end of the spectrum and feel like we need to learn more so that it's not as unknown. But there are other people on the other hand that are, I think, very excited about the prospect that this could solve some of the problems in a serious way. So I'm probably more on the frightened end, but maybe that's just my personality.
No, I mean, when I talk to public audiences about this topic, I always use Churchill's comment about democracy. That it's the worst form of the government, except for all the others.
Right, so this may be the worst solution except for this.
Yeah. Britta?
I'm also frightened, and luckily I've maybe sidestepped the resistance, just being in philosophy as my main discipline. I tend to be a little bit more maybe open to radical, crazy ideas, so I haven't encountered that so much, but I think I certainly want to keep working on this topic, and I think one important sort of move to make is away from questions of deploy or not, research or not, but broader questions like the ones we've been talking about. Who would control it? I think one thing that's not often mentioned is connections with militarization, and the relationship between solar geoengineering and other aspects of the energy transition. So we're starting to see solar geo being plugged into integrated assessment models, for instance, and when you do that, what you see is a large amount of mitigation inhibition. And so there are deep philosophical questions there, I think, about how solar geoengineering and other aspects of the energy transition should relate, and it's not easy.
Basically, by decreasing the fear and therefore the drive to spend more money to actually push the energy transition forward.
Can I just add one thing? There were these experiments.
It's a can of worms, sorry.
There were these experiments that people did, admittedly kind of lab game theory experiments, where they showed that actually adding solar geoengineering in the mix actually frightened people into more mitigation in some cases.
People have made that point. What actually happens in the real world?
So that's different than the plugging it into a.
That's totally
Yeah,
true.
yeah.
Totally true.
Robin, any thoughts?
I would just add that I outside the scientific community at least, I expect the way this is going to play out in the next 10, 20 years will depend a lot on events and extreme weather events in particular. And so the current context we are operating in could change significantly if things get bad, as in the more pessimistic scenarios and projected emissions are not going in a favorable direction.
Yeah, I mean, I think unfortunately one of the things about a lot of people in the climate community is they actually don't understand energy systems very well. And so colleagues of mine in climate science who say that this discussion is a bad discussion, we shouldn't be talking about solar geoengineering. I say, well, what do you think we should be talking about? They say, oh, we should be reducing emissions. I say, oh, of course. Why didn't we think of that? We should reduce emissions. Of course we should. But it's a little more complicated than that. There's lots of wonderful people here in the audience. I'd love it if you keep your questions relatively brief, because there's a lot of you. Let's start right here.
Hi, I'm Greg Bonner. I live in the area, and I work at the intersection of AI and sustainability data. So great panel, but I have to sort of ask, why hasn't anybody mentioned termination shock yet? Because that's the $1 million question, because my understanding is from a Harvard grad student that you put it up, it will definitely cool for 2 years, and then when emissions keep going up and we're not doing anything, and when it all, after 2 years, we simply don't know what's going to happen. And that's really the $1 million question.
Yeah, I mean, I think of termination shock as not just doing it once for 2 years, but imagine we did it for,
Well,
and ramped it up to a substantial level, so we had a lot of particles reflecting a lot of sunlight, because CO2 levels got very high, and now for some reason,
but emissions keep going up.
yeah, but now for some reason we're addicted to it. You know, Frank Koich is the person I always quote when I talk about this. Frank, do you want to tell us your analogy? Because I think it's the best one I've heard.
Oh, so I compare so stratospheric soil engineering with opiates. I say they're like really strong painkillers in that they only treat a symptom and not the actual cause, right? And then I say that you can get addicted to it if you don't, if you don't actually address the cause. In addition, like any painkiller, you're gonna have side effects. The idea that you can't have a painkiller, the painkiller that's strong without side effects is not true. And then there are withdrawal symptoms, and that's termination shock. And I can tell you that for me, from the physical science perspective, termination shock is the biggest concern, right?
I would say that actually gets to Billy and the governance issues too, because as soon as you say, okay, there's side effects and and those side effects depend on exactly how this is done. For example, imagine a scenario like in Ministry for the Future, where the Indian government started doing it and did it badly. I can't imagine the US military now immediately taking it over, because if somebody else is going to do it badly, we want to make sure it's done properly. Or some other country will.
Or at least we can try to do it badly.
Yeah, and frankly, make sure that it doesn't terminate abruptly for the reasons that we're talked about. So anyway, let's keep going. David.
I'd like to ask an economics question. The panel is not very optimistic about the science or the engineering of stratospheric solar geoengineering. That's my right. I don't hear a lot of optimism. I hear a lot of doubt. Secondly, the politics is completely unknown. How you control this, manage, even controlling an experiment, let alone controlling actual geoengineering. But you haven't mentioned the economics. Roughly costs $1,000 to put a kilogram of anything, sulfur or anything else you desire, into the stratosphere. How are you ever going to afford to put hundreds of millions of tons of material into the stratosphere?
So, go ahead, Billy, but
Well, I mean, you gave me a lot of credit at the beginning. I've been dabbling in this for 3 or 4 years, but the calculations I've seen are that it's actually very cheap. And the challenge with solar geoengineering is actually what they call the free driver problem. It's not the free rider problem that we have with mitigation. It's that whoever wants to do the most could actually control the thermostat, so to speak. I mean, that ignores military conflicts and everything else. But I think the challenge is that, to me, just to go to your original question, I mean, I think we could do it very effectively if we could figure out how to control it. I'm just very skeptical that we could do it in a way that could actually control the process in a fair and equitable way, or that we'd actually get to that point. And I'm also concerned we don't really know all the side effects until we were to actually do that at-scale experiment, which itself would have a lot of risks.
I was on a panel with a bunch of folks, or Jason, physicists who were working for the Defense Department. And they did a variety of estimates of different techniques for how to get particles up there. Their estimates were consistent with everything else that's been published, which is actually doing a serious program in this, real deployment of a solar geoengineering project would be in the range of a few billion a year to maybe a few tens of billions of dollars a year, which in the context of the global energy system, let's just remember, we are just starting the decarbonization pathway, and we spent 1.7 trillion on clean energy last year. So this is essentially free. I mean, it costs nothing compared to decarbonization. So let's be really clear about that. The economics are remarkable.
It's actually
one of the problems.
They collect the cost because
Yeah.
they're so small.
They're so small. Yeah, please.
Two-phase question. I don't understand why the fossil fuel industry hasn't seized on this as yet another fake panacea that they can promote to let us keep selling all the fossil fuels we want to. And stage 2 is, if it is so frightening to the population at large, why can't it be used as a political lever to get support so we don't have to go to these extremes?
I'll say, my impression partly is that if you say, if I understand you correctly, that you could just use this and keep on burning fossil fuels, that way you actually, then you're actually admitting that fossil fuels are really doing bad things, right? So I think partly, that's been the people I've talked to, I think is part of the reason why that hasn't really happened. And it's also still kind of a fringe topic, so I think it's just not that widely known.
Yes, please.
I'm Bill Beckett. The leading candidate aerosol is sulfuric acid. I'm just wondering what the environmental fate of that sulfuric acid is. Does the sun break it down? Does it fall to the earth? Does it go in the ocean?
I'm sure Frank can weigh in on this as well, but yeah, lots of things can happen. So it doesn't, of course, stay in the stratosphere. It rains out eventually. Sulfuric acid aerosols are great for cloud seeding. So one of the things we haven't mentioned yet, but is also important, is you change cloud distributions by aerosols raining out of the stratosphere and into the middle atmosphere. My understanding is that the effects on pH of water systems on the whole is likely to be not that large, just because it's globally distributed, and the concentrations on a planetary scale can cause radiative forcing, but they're not locally large enough to really perturb things. So I think that's an ongoing research area.
So,
Maybe just one more thing I would add as well is that another thing we haven't mentioned here is that this perturbs the biosphere, because if you have higher CO2 concentrations, but you also radiative forcing, then you're going to change plant productivity in a direction that we don't fully understand yet.
So just so you understand, the stratospheric circulation is essentially two big cells rising at the equator and then falling to the poles. It's called the Brewer-Dobson circulation. And what that means is particles that you put in the stratosphere, in general, are mostly going to fall out at very high latitudes towards the poles, where not very many people live. So, in the high Arctic or the Antarctic, this is not a place that is tolerable. But the other thing you have to understand is because they last so long, the amount you have to put in is tiny compared to what we're doing in the troposphere. It's nothing. So it's like less than 10% of what we do today from burning bunker fuel for ships or coal burning around the world. So the amount of sulfur we would put in, and it's not clear to me that it would be sulfur, but I guess the jury's out on that. But if it was sulfur, it's still a tiny amount compared to what we're already doing with coal. So you keep that in mind. But then coupled with the fact that the effects are going to be highly focused on the poles, where basically nobody lives. Yeah.
I think about lower tech approaches to geoengineering. So, one that came up popularly is having roofs painted white. Is there any, first off, do those kinds of things have any impact, or maybe they're just trivial? And then second, we're talking about something that is highly unknown. Are there other geoengineering approaches that are lower tech and therefore perhaps lower risk?
It's a good question. Does anybody, Frank or Robin, want to talk about that? I can also.
What I'll say is, if you want to, by reflecting, get a certain amount of energy sort of out of the climate system, you're getting a certain amount of energy out of the climate system. And as Dan and Robin were saying initially, as this is solar and not in the infrared, that difference will persist no matter what you could do. You can imagine space mirrors, right? And you'll still have that difference there. And what I think is that we should think about all kinds of different approaches, because the idea that there's just this one approach and that'll be great and do it, the silver bullet is utopia. So I think and also the most likely way to, for example, get around a contamination shock is to have multiple different approaches that you're using, each in a smaller amount. So white roofs, a lot of white roofs to have an impact, but I think all these approaches really should be considered.
I just add something quickly onto that as well. So yeah, to make that into comparison, again, this surface area versus volume argument really helps. So, as you get smaller particles, you can get a larger surface area for their volume. If you're painting a roof white, then the area of the planet that you would need to cover with those white roofs in order to get a comparable difference, or for a space mirror if you want to go that far, the amount of mass you need for that is vastly, vastly greater than what you would get with aerosols in the stratosphere.
There's also another really important issue that connects the time scale with this problem. If you care about things like termination shock, in my view, the time scale of a year or two is actually kind of a sweet spot. For example, some people have said we should do cloud brightening very low-level clouds that we could brighten artificially or create them. And the reason that terrifies me is the timescale is like days to weeks. And I don't want a solar geoengineering system that you have to like operate on a day-to-week timescale, because imagine there's a war that breaks out, or imagine there's some problem. Boom, talk about termination shock, right? Having the timescale of a couple of years, you don't want it to be forever. There's some people who have suggested self-levitating particles that would be permanent in the stratosphere. That I can't get to yet. But having a timescale of a year or two that it's going to wash out, if it's a problem, it'll go away, but not so quickly that, you know. So to me, there's a really interesting relationship between timescale and control here. Yeah, in the back.
Yeah, just one thing about the white paint. It reduces the heat island effect, so it keeps people alive in the summer.
Yeah, it's an adaptation effect for sure, but that's different. In the back here.
Are your peers in, say, People's Republic of China having the same conversations? And what is the multilateral, regulation that would prevent China, for example, to, come just advance to, solar engineering? And how do you think about that?
Those are really good questions. Bill, you want to talk about this? I've talked about this with Chinese colleagues too.
Well, I'd be curious what you've heard. I haven't had any direct conversations. I mean, it's the Weather Modification Treaty, which I forget who is in and out of that, which would have some bearing on this.
No, the Weather Modification Treaty only covers intentional modification for adverse effects. That is, so if you're trying to do it with good intentions, or you claim good intentions, the Weather Modification Treaty is out.
I wasn't even sure who was in and out of that at this point. But my impression, well, Dan, it sounds like you've had more conversations than I have.
Well, about 6 years ago, David, Keith, and I went to spend a week in China talking with colleagues at Tsinghua and the Chinese Academy of Sciences. And it's very interesting. They were very cautious about talking about it. I think the Chinese government had sort of put down the word that this was not an appropriate topic for a dialogue between the US and China. I don't think because they were doing it secretly and wanted to protect it. I think for the very simple reason that they wanted to, frankly, keep the thumbscrews on us for actually reducing our emissions, and they were doing a lot, and they wanted to see us follow. I will say, Joe Aldi and I, and a colleague of ours, are trying to start a Harvard Tsinghua University dialogue on this topic, and really convene a group of Chinese leaders and US leaders in this field to create that dialogue. I think it's a really important dialogue to happen. The current tensions between the US and China make that really challenging, but I hope we can launch this anyway. Other thoughts? Yes, please.
I'm curious to hear your thoughts on the USS Hornet marine cloud brightening experiment and Alameda County's response, what perhaps could have been done differently. And also, given that this is a global commons public good issue, what role do you see particularly for philanthropy in research in this field?
I think what happened with the Alameda experiment, quite honestly, is that after the experiment they tried to go a slightly different route by having as little publicity as possible. I believe they did engage with the local authorities. My best guess, which I don't know, is that the local authorities did not understand all the focuses would draw on them and being sort of in the bullseye. The actual experiment, you go walk on the beach and there you say breathing sea salt is good for you. So the actual experiment itself is it does do promise, but it does nothing. I think I think my lesson from this is that it shows that if you do an experiment in a community, you really probably have to take some way of spending the time in engaging with that community. But I don't know, I think it's very unfortunate that the experiment was shut down from a scientific perspective, but I think there's an important lesson in that.
Berta, what do you think about philanthropy?
That's a great and difficult question. I think that it depends obviously on the philanthropic sources, and we know that a lot of them do have connections to the fossil fuel industry. And going back to that question earlier, I think even though we're not seeing this narrative of, oh, this is a quick fix, I wouldn't be surprised if that's something that happens down the line, and I think we should be wary of that. I'm also quite worried about the sort of public corporations trying to do this. So there's a couple of startups that are kind of trying to enter this space with, as I understand, very limited actual impacts, but a lot of publicity.
There are startups who are actually putting sulfur in the stratosphere.
Little
It is
balloons.
insane, but they're doing it, yeah.
Yep, you can buy merch, apparently.
I saw them at this conference that Bill and I were at in Houston, and I actually said, you know, like the Wagner Group in Africa, there's certain things that just shouldn't be private, and this is one of them.
Yeah, I think that, just to add to that, I mean, I think figuring out the right balance of engagement and governance, but not letting that be a total, you know, looking for a consensus that is going to obviously not be achieved. I think figuring out that balance is kind of what, between Frank's experience and the Almeida experience, people are trying to grapple towards. And obviously, you know, philanthropy is plays a very important role in research, so I wouldn't want to say anything too bad about that. But I do think figuring out the right governance strategy and the right rules about transparency and sharing and equity and fairness are going to be pretty central. Exactly who funds it, maybe less than all those other pieces at the end of the day.
Please.
I wanted to come back to the shipping story, and it feels like it was sort of a surprise that we've had this pulse of warming once we cut the emissions. Was this missed by the modelers and the policy experts as the unintended consequence, or do we know that, well, you know, the local pollution impact is so bad that it's worth this broad risk? And I guess maybe relatedly, is it not a natural experiment that, I know there's lots of study of it, but as we think about the rate of rolling out those restrictions on the emissions, could there be a natural experiment where we slow down that phase out in the interest of studying the impact and learning?
So it wasn't a surprise. Plenty of climate scientists knew that reducing sulfur emissions was going to cause warming. We've known that. And yes, the health impacts of that are really well worth it still. I don't know, Joe or Billy could probably cite the economic analysis that looked at that cost benefit analysis.
Do that. This is the conversation we had about at our conference, was whether or not you might do a tropospheric intervention in a really dire heat wave sort of scenario and live with the air pollution costs for some period of time. But you know, in general, no, it's not. It's not going to be worth it. And those sorts of forcings are like in the standard tables of what's going on in the atmosphere. So
Now, as far as the natural experiment part, I will say even Mount Pinatubo, which is often cited as the natural experiment, if you get into the really details of exactly how much cooling they've caused, it's really hard to figure out, because it turns out that it was in the middle of an El Nino cycle, and there was cooling that was going to happen anyway. And figuring out what was actually going to happen, and it turns out that this warming is on the backs of a big El Nino, and we expect the Earth to cool now, and maybe it won't quite as much, but trying to attribute it is really hard. So the whole issue of attribution in the climate system in general is really hard. It's actually an issue I was going to ask you guys about. If this system, if a solar geoengineering system ever did become operational, if a country or a consortium of countries ever did this, I can promise you that the first unusual climate event that occurs, they're going to blame on this, whether it was caused by it or not, right? So it's going to be scapegoated for everything. How do you think about that?
I mean, I think it's a real problem. I mean, we had some conversations about this, that we already see that with climate change in general. You know, people talk about the probability of how much more likely something is because of climate change, and certainly with this sort of activity, one thing that's been talked about is trying to improve attribution science, so at least you can have more authoritative information out there, but that's not going to stop people from just saying whatever. And
that might even make things worse. As I said, it might give more responsibility where it's not necessarily appropriate.
Yeah, so I think and also once you legitimize interventions, how many more interventions will you see? That's been another issue that's come up, but those are just some of the things I think you have to think about from some sort of a chaotic intervention.
Well, listen, we're over time, but this is not going to be the last conversation about solar geoengineering that's had at Harvard. nor anywhere else. And we hope actually that this is a conversation that will continue all over the world. So join me in thanking Robin, thanking Billy, thanking Sarah.